So we were talking about scientific notation. Scientific notation is a shorthand way to write a really large number, or at least a number that maybe it's really, 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 really small, but it's got a lot of digits. Okay? So you probably saw in the video already, scientific notation comes in this form. There's only one digit, maybe it's a 3 or 7 or whatever else, and then there's a decimal. Okay, only one digit before the decimal, and then you could have maybe it's just a 0, or maybe it's a couple other digits. You might have a few in there. You're basically going to as many non-zero digits as you need to, and then you're going to multiply that by 10 to some number. We're going to start by talking about positive numbers. In other words, a number that's really big. Okay, so where might we use scientific notation? To talk about really large numbers, and instead of having 3.07200000000, we write it like this instead. When would you see that?
Like money, like 1.5 million or something.
If it's only in the millions, we'd probably write it out. I mean, you could do scientific notation there, but we're talking about like not just millions or billions, but once we start getting up into trillions or larger than that, that's when you might see scientific notation. I think the best example that I can think of is when you're talking about outer space. How many miles is it from Mars to Pluto? You're talking some huge numbers. And instead of trying to write that out and then actually say it, a lot of times we'll list those in scientific notation. Okay, so here's how this works. If you've got a large number like 15 million, and again, I think that's a small enough number, we'd probably just write it out. But we could write in scientific notation. You're essentially just going to look for, you start over here and stop when the rest of them are zeros, which is just those two, right? Because all the other digits are 0. Okay? The ones that I underline are what go here before the times 10 to the whatever. So I'm going to write this as 1.5, except for I'm going to put it as 1.5. Remember, one digit in front of the decimal? And I'm going to multiply that times 10 raised to some power. Well, how large of a power? And here's how we figure that out. This is where the original decimal place is, right? Even though I don't even have it written out. And now I'm saying I'm going to move it to in between the 1 and the 5. Well, how many spaces did I have to move it? 1, 2, 3, 4, 5, 6, 7. So this must be 1.7 times 10 to the 7th power. Those two things are the same. This and 15 million are the exact same number. Which one would you rather use? Would you?
No.
In my case, I'd rather use this. But only because it's a small enough number that I can kind of comprehend and grasp 15 million. It doesn't take too long to write it out. It's not that difficult to say. But once you get into more complex numbers like this, what is that, by the way? How would I say that number? Yeah.
400
Not trillions yet.
billion.
We're into the billions. Now we're starting to get to that point where I go, maybe I want to start using scientific notation. And again, I look at this and say, well, that's my only number that's not a 0. So I could say 4. I do need to have point something, so I'm going to call it 0.0. I'm going to multiply that by 10 raised to some power. Well, here's the original decimal point. Here's my, I guess you could call it the new decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 4 times 10 to the 11th power. 400 billion. Okay? Let's take a look at a few more. This one becomes a little trickier. What makes this different, even though it's a smaller number, 5,090,000, what makes it different than the other two? Amaya? Yeah, I've got kind of a 0 wrapped in there, but then it goes back to a non-zero digit. I do the same thing. I'm looking to go from here, and I keep going until I get to my last non-zero digit. Okay? So I need to take all 3 of these, the 5 and the 0 and the 9, and I'm going to rewrite them as 5 1.09. Times 10 raised to some power. So again, here's my original decimal. Here's where it's going at in scientific notation. 1, 2, 3, 4, 5, 6. Are we good there? Okay. Try doing the same thing with 250 billion. First of all, write out 250 billion longhand, and then change it into scientific notation. That's a lot of zeros. Good. So how do I change it into scientific notation now? Should have 2.5 times 10 to some power. Stand up if you've got it. Two 2.5 times 10 to the, Anya, did you get it? Not sure? Did you get this point? Did you wrote this out, I know that. Did you get this structure where you recognize, hey, I've got to have 2 and 5? 2.5 times 10. So now really you're saying how many times did I multiply 10 to move the decimal from here to there? How many is that?
I counted 12.
You counted 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I counted 11.
Oh.
Hey, didn't you have 10? You counted 10, you counted 12, I counted 11. I think we got 11. Did you get 11? Yeah. Good? You had 10 too? So maybe we just miscounted a little bit? Or did you write this incorrectly in the first place?
I think, yeah, that's
Okay. Alright, take a seat. Now we're going to do the opposite. We're going to start with the scientific notation. And we're going to write it out as the longer standard form of a number. So I'm starting with 3.4. I'm just going to write my decimal in a different color. And I'm going to make a much larger number because I'm multiplying it times 10, times 10, times 10, times 10, times 10, times 10. So I'm going to have a whole bunch of zeros. Okay? So here's how I like to do this. I'm going to write a bunch more zeros than I really even need to. And I'm just going to move that decimal place over from 3.4. I'm going to move it over 6 times. So I go 1, 2, 3, 4, 5, 6. I can do that on a smartboard. If I'm doing it on pencil and paper, I probably draw like little bumps underneath, right? So now that means I don't really need all of these extra zeros because my number ends right there. The last thing I would do then is just put in some commas so it can kind of make some sense out of it. 3.4 times 10 to the 6 is the same as 3,400,000. Okay? Let's do the same thing with this. 1 times 10 to the 5th. Well, again, I'm starting with 1. I guess maybe I could write it as 1.0. I'm going to make it a much larger number by moving the decimal places over, and I've got a bunch of zeros. So add as many zeros as you want there. Move the decimal place over 5 times, because it's like I multiply by 10, multiply by 10, again, again, again. Right? 1, 2, 3, 4, 5 times. Did you end up with this number right here? 100,000. Okay. The biggest thing with this one is just making sure you move it over the right amount. Okay, you don't want to take that big number and multiply it by 10 again, so now you suddenly got this extra large number. Try 9.3 times 10 to the 7th on your own. Stand up when you're done. It's trickier because not your units there aren't
Oh,
matched
yeah.
up. What do we have? Jalen, what's this number?
93 million.
93 million? 93 million?
Yeah. Think so.
000. Agreed? Yes? We agree with her?
Yeah.
You gonna double check, yeah? 9.3, that means from 9.3 down to the end should be 7. 1, 2, 3, 4, 5, 6, 7. Oh yeah, 93 million. Alright, take a seat. Try the last one. We've got a comparison. Just like we could say, is 9 greater than 12? Greater than, less than, or equal to? We're gonna say greater than, right? But instead you need to calculate first. So write these two numbers out in their standard form so that you can clearly compare them. Noah, did you get that one?
Yeah.
The two numbers I got were 12,000 and 2,100. Did you get the same, or did I make a mistake? That's what we got. Okay, so once you see that, like down here, you look at the scientific notation, go, I don't know quite which one's bigger. When you write them out, it's pretty clear, right? 12,000 is a much larger number. What maybe would tell you that down here? Could I just look at the first couple numbers and say, well, 1.2 compared to 2.1? That doesn't work, does it? That seems like it's the smaller number. So what makes this a larger number? Am I, yeah, how many times am I actually multiplying it by 10? Okay, so that's gonna make a big difference. Good? Questions on scientific notation? All right, we'll take a look at what we've got on Google Classroom as practice for today.